to do a couple chemistry heat problems. The rest will be yours to do at home. We are going to be using the delta H equals Q, which equals M, Cp delta T. Okay, so we're going to be using a specific heat equation. Basically, it's a plug and chug. Plug in what you've got, figure out what you don't. Okay, so as we go through, I've told you this a couple times in different things, if you've been in my class at all, is that I like to go through and identify what I have and identify what it is. So, the specific heat, excuse me, of ethanol is this. That's Cp. Find the heat energy. That's Q. Required to raise the temperature of, here's a mass. And here are my two temperatures. This is T initial, this is T final. And I know that delta T is equal to T final minus T initial. So now I just have to plug in. So Q, that's what I'm trying to find, is equal to mass, 193 grams, times specific heat, 2.46 joules per gram degrees Celsius, times delta T, which is T final, 35 degrees Celsius minus 19 degrees Celsius. I plug it into my calculator and I go. My answer should be in joules. How many significant figures should I have? 3. Good. So plug it through. What do we get? Actually, we should only have 2 because of our temperature. Anybody got one answer? Okay, what did you get? 7,596. So if I did it right to 2 significant figures, it would be this, right? Now, this is a nice little worksheet because on the back, if you look down at the bottom, it has all the answers. So is that answer there? It is, it's there. It's there, so circle it, cross it out, and on this side, circle it. So this will help you to study for the test because you're going to have some like this, and you have the answer so you know if you did it right. Okay, we're going to do one more from the back side. Back side is more like the lab. Okay, we'll do this on another piece, another page here. Okay, bringing this up a little bit so we can see it. Give us some room. Okay, again, I'm going to identify what I have. Actually, this time I think I'm going to read it through first. So it says a 150 gram sample of water, initially at 45 degrees, is mixed with a 200 gram sample of water, initially at 84 degrees. Find the final temperature of the system. Okay, I'm one of these visual people. I want to see what's going on. So, okay, I have one sample here, and it's 150 grams, and it's at 45 degrees Celsius. And then I have another sample right here, and it's 200 grams, and it's initially at 84 degrees. And then I'm going to pour both of them together into here, and I don't know what the temperature is going to be. Is that basically what it said? Okay, so each of these will have an amount of energy that will be given in or taken in or given off, right? And it has to be the same. So this is like our lab. When we moved the metal in, the metal gave off so much, and the other gave in. The nice thing is, the CP for both of this is 4.184. So guess what? The CPs are going to drop. I'm going to set them equal to get each other first. So I'm going to go mass times the CP times delta T equals mass times the CP times delta T. The CP on both sides are the same. Everybody okay with that? So they're gone. Okay? But my delta T, I can't really put a delta T in because over here, let's look at over here on the left. Is it going to get warmer or colder? It's going to get warmer, right? So my final temperature is going to be higher, right? So I'm going to go T final minus 45. Everybody go okay? That's going to be my delta T. Okay? And then over here, my delta T is going to be warmer or colder? Colder. So I'm going to go 84. Whoops, my final temperature. Let's try that again. It's going to be colder. So 80, let's see. Final temperature colder. Final temperature hotter. I want it delta T to be positive on both sides, because then they'll be equal to each other and won't totally cancel each other out. So I'm going to go 84 here minus T final. Okay, because I want my delta T to be positive. So I don't have to figure it out. Okay, so now I'm just going to replace the T's in here. So I'm going to call this 150, I'm going to put the mass in, times TF minus 45 equals 200 times 84 minus TF. Everybody know how to distribute? Okay, so I'm going to go 150 TF minus, somebody do this, I'm not going to do it in my head, 45 times 150. Yeah, I've already got the negative one. 6,700. Okay, equals, do the 200 times 84, because I'm not doing that one in my head either. Sorry. Minus 200 TF. Okay, what side are we going to move the TF to? We want a positive, right? So we're going to add 200 to this side, TF, add 200 TF to this side. So I have 350 TF minus 750 equals 16,800. So I'm going to add this to both sides. 350 TF equals 0.5532, right? I'm just solving down for TF. Okay, divide both sides by 350, and temperature final should be between these two. If it's not, then I screwed up. So it should be between these two. What do we get? 67.3 degrees Celsius. Is it between these two? Yeah. Awesome. Is it down at the bottom? Ta-da. Okay. Now, just the ones on the back are going to be like this. So you only have two problems like this, okay, where you have to set two things equal to each other. Okay. The other side is just the chip plug and chug. Okay, look at your other stuff real quick. Going to bring, I hope it's still up. Okay, it looks like I'm going to have to bring it up again. Be patient with me just for a second. If I can find. Okay, while we're waiting, what I want you to do is look at your combustion engine thing here. How many are into cars at all? Is there a difference between a regular car engine and a diesel engine? Yeah, there is. Okay, and so what we're going to do, and I'm going to come back to this. Okay, there is a difference between a car engine and a combustion engine. On the first one, this is a regular car engine. Okay, you have the point at which this is sort of like a freeze frame. You've got the intake, then a compression, then a power, then an exhaust that happen. Okay, and it just repeats over and over and over again. If we turn the page here, we've got a diesel engine. The same kind of thing goes on. We still have an intake, we still have a compression, we still have a power, and we still have an exhaust, but it's about a different kind of process as far as what's happening. the mechanics of it. Okay, so what we're going to do is we're going to be reading this little packet here, and you can do it in pairs or you can do it in your foursomes or threesomes. So like you guys remember your pair, you guys are a pair, you guys are a pair, you guys are a pair, and then my back row, and you can fit in wherever you need to. Okay, you're going to answer the questions in your little packet like this, and the first page is just answering questions. And then you get to the analysis. So the first page is just reading it and figuring it out. Then the analysis. This is where you can use your phones to research data. You can use the computers to research data. But it gets a little bit more hairy over here as you research more stuff. What are your environmental concerns? What's the cost of fuel? What's importance of the longevity of the engine? What are maintenance costs? And then your initial cost of the vehicle. Which should you choose? Should you choose a diesel? Should you choose a regular? So we're going to go through this and figure this out. If your group gets done, great, wonderful. Turn it in. Make sure you put your name on this just in case it gets misplaced, because we forgot to put a place for a name, and a lot of kids have forgotten it already today and misplaced it, and I can't get it back to them because I have no idea who they are. Okay? These two things are due next time. Okay? So your heat problems and checking for understanding are due next time. You should be handing in your lab that we just finished. I am going to bring you back together about between 5 and 10 after, and we're going to do that review Kahoot. Okay? Questions? So the rest of the time is yours. So you got about 30 minutes, a little over 30 minutes. Okay? So you're going to take this divided by this, times it by 100. Once you get that answer, take 100 minus that answer to get your percent error.